In this video, I am going to explain how to train a StarDist deep learning model to find a specific class of objects. Some things to consider before training a new model. Training is simplified by cloning a model rather than training a new model from scratch. First, is there a pre-trained model which is similar to your samples? If a pre-trained model does exist, test the model on your images first. If you're finding the objects of interest, the model options may be adjusted to provide a better segmentation. Once it is determined there is a need to refine the model with additional training, the model may be cloned from the AI Deep Learning Prediction panel. If no model correctly segments your objects of interest, then a new model can be created and trained. In this example, I will use images from a mouse testes tissue sample and segment the sperm cells. Ultimately, we want to classify these cells. But the first step is to provide an accurate segmentation. For convenience and training purposes, I have cropped out a few sections from the scanned image. This is the scanned image. First, select the Count Size tab. Next, select the Model Manager. After the Model Manager is displayed, you can then select various categories of models, depending upon your configuration of imagepro AI. In this case, here are all the pre-trained models. Next, I'm going to select the Life Science Optical. Here are all the pre-trained models available under that category. In this case, since I'm segmenting labeled nuclei, I'm going to select the hematoxylin nuclei. To test the model, I'm going to load the model in the Predict panel. This will load the AI Deep Learning Prediction panel with the correct model, the hematoxylin nuclei. Next, I will select one of my images. The Deep Learning Prediction panel contains a number of sections. The first is Load Model. The next is to configure the classes. In this case, I'm going to select the class color so I can easily see it on this image. So I'm going to set that to yellow. And I have other options here, such as random and filled, but I want to see the outlines of my nuclei. And I'm going to set the line width to 3 pixels. This makes it a little bit easier to see the outlines. In configure classes, I can also name my objects of interest. In this case, I'm going to call it cells. Under Select Targets in Step 3, in Section 3, I am selecting the target for segmentation. In this case, this is an RGB color image. And now I have a number of options under Set Model Options. This is key to providing a correct segmentation. The most important one is object diameter. This needs to be set to the average diameter of the cells. I'm also showing a size guide display. It's currently visible in red. This is a little bit hard to see. You can see it here as I zoom in. The red on top of the purple color makes it a little difficult, so what I'm going to do is change that color so I can see it, and I'm just going to make that yellow also. The key here is to set the size guide to the average size, roughly, of my objects of interest. This looks good. Again, I have a range. So in this case, I have the larger immature ones, the maturing cells, and the fully matured cells. So I have a range of sizes. We can also turn the size guide display on and off, which may become useful later when you have counted objects on the image. After setting the size guide display, I have 2 other options. They're set by default. One is the threshold. This I can raise and lower accordingly, depending how well I'm segmenting my objects of interest with the deep learning model. Since this is a StarDist model, I have an option called maximum overlap. I'm not finding overlapping cells, so I'm just going to turn overlap off. Now I can test the model. I'm going to press the Count button under the Predict and Count section. This will then run the prediction model based upon how the model was trained, and then we can see how well we're segmenting our cells. At various points in this video, I'll be running a prediction. For convenience, I will speed up these sections. All right, as you can see, we missed a few, found a few false ones, and we're missing our smaller ones. So now, this is where I can adjust my parameters to see if I can properly identify my cells. The first option is should I make this smaller? So let me bring that down to a size of 3. And I can retest that. As you'll notice, I'm now doing a little better job finding my mature ones. I picked up a few more false ones, and now I'm missing some of my large ones. So I'm now going to make another adjustment. I'm going to go back to a little bit larger, set that to 4, and I'm going to lower the threshold a bit and bring that down to, say, 50. What I want to do is see if I can do a better job of identifying my cells. What's nice is this model is already highly accurate. What I only have to do if I do need training a little bit more. So now I'm finding the trade-off of I'm really doing a very good job picking up my cells here. I'm picking a lot of my more mature ones, and I have a few false positives. So this will be an easy image to edit when I'm ready to do some additional training if needed. If I want to test another image, I can simply select another image, and I can test. Okay, now I'm finding a few more false positives, so I'm going to raise that threshold just a little bit more so I'm not finding as many of those, so I have to do less editing, and I'll press count again. So now it's clear that I need to provide additional training to the model. To do this, I can select the clone model from the bottom of the AI Deep Learning Prediction panel. Now I can press the clone model. Since I'm cloning the model, most of this information is already preset. It's an instant segmentation, so I'm looking for objects. The StarDist model is very good for finding round or elongated objects or cells, which this is the case. I'm working with a color image. Configured classes. This will be set in the training panel. I am using a StarDist model, and under the Adjust Training Set options, here there's an option to copy the training model. This is the parameters that are already set with this model, and since I'm accurately finding my objects of interest, I want to leave this check. Otherwise, if I uncheck this, it will now be a naive model, and I'll have to train it from scratch. Now, I can enter the name of the model. In this case, I'll call it under description. I can give more of a description for what the model I've created. Say it is cloned from this particular model and is created to find the cells. In addition, I can put specific tags, which will allow me to tag metadata to the model. For example, this is bright field. I can add other tags, so I can use to search for a particular model. I also have the option to, if I want to take a snapshot, in the model manager there was a little thumbnail of an image. I can create a snapshot to put there so I have visual reference for what the model is doing or what it was trained to do. Finally, I can add a demo image later that if I want to distribute the model to someone, I can include a demonstration image that they can walk through the model and see how it works. Finally, load in trainer. This I'll have on to load the model in the AI Deep Learning Trainer. So now a couple of important things have occurred. I've loaded my model. I can configure the classes. Again, this was cloned from the original model, so I'm just going to set this to yellow to make it easier to see. And set that to 3. And I will call this cells. There are a few other important sections of the trainer panel. The first is select regions to label. I can label the whole image, or I can take individual regions of interest and add those to the trainer. The purpose of this is if I have bad sections of the image, I can avoid those. Or if I have an image where I need to mark up hundreds and hundreds and hundreds that I have to manually draw them, I'll typically want to start with smaller sections and build the model. The next section is label all objects in the defined region. One of the most important things about deep learning is using region of interest or the whole image, you must mark up everything. You cannot leave some marked up and some not marked up. The model will never come to a good solution. And for defining or creating the labels, basically outlines around we want to measure, is I can manually draw them. We have brush tools, polygons, magic wands. We also have some object splitting and erase tools. Segmentation, this will allow me to use smart segmentation or machine learning or manual threshold. And finally, we can predict with the existing model. In this case, I can load the prediction panel, which is already open, and I can use an existing model to predict as a baseline to start finding or start marking up my image. I've already done this in essence by running on this hematoxin nuclei. Then finally, when I have a region or regions or image properly labeled, I can then add this to the trainer. As you can see, I already have 849 labels. After I've added a few images to the trainer, I can then run a training session. Once I've done that, I can then run a predict operation to go to an image that's not in my training model and run a new prediction on that based upon my trained model and look for the improvements. So how do we train this model now? How do we label it? In this case, I'm going to start with a small section. Here I'm going to start with an ROI for just an easy to understand how to go about labeling your image. Since I already have objects on here that are incorrect, so let me delete those first. Here I'll just delete a couple of these that are incorrectly labeled. I can also hold down the control key and select a number of them. In this case I have a number of them, so I can just select all those at once just to make it easier and faster. I can press the delete key on the keyboard, or I can delete those selected objects. I don't want to delete them all because I don't want to delete everything in the whole image. Now, let's see if I have any objects. Right now, just that little section is properly labeled. I have one other area. Let me add one more here. These two. So how can I do this? I'm going to manually draw those in with a brush tool. You can see my brush, it's a large size. As I zoom up, I can either zoom up the image or I can hold down the control key and dial in that brush, whatever is appropriate. So I can just draw that in, and now I can actually draw a couple of these in where I'm missing some. So there's one. And you'll notice I went over the boundaries. That's okay. There's a feature here called Merge and Edit in this drop-down, which would allow me to merge these together. At this point, I want these to be separate objects, so I'm not going to do that. And now let's just zoom up and draw in a couple more. Here, some of these may be a little questionable because they're just at a slightly lower area in the tissue. So now I will validate these objects. And if I make a mistake, I can do one of two things. I can select one and delete it, as we know, or I can use the erase tool and just erase those bad edges to have a much better segmentation. I'm going to turn off the erase tool. As you can see, I have all my labeled objects. So now I'm going to our cells. And so now just this one small region, I'm going to add as a training source to the training set. So I'll press Add. This will now bring up a dialog called Add Labels. There's a couple of pieces of important information here. Or it's reminding you that have you labeled all the objects in that region. If you have, it's just telling you this is the source image and this is the training channel, in this case color. If I've already used an ROI on this image, but I'm just in a different section, you'll have additional information to confirm. But the key is I'm only adding from this region of interest. Once I add that to the training set, you'll see the information under the training set change. Now that that information has been added to the training set, I can delete this ROI and select another area of the image, or I can work on another image, section that I've cropped out. Let me take a small one here, and I'll show you how to use the predict panel from the deep learning trainer. In this case, I'll choose predict with existing model. Pressing the prediction panel will bring up this panel if it's closed. And now I can simply press the count button. This will run the prediction on this image. And so let's make a few edits. So now that I already have most of the outlines correctly identified, I can now come in, select, and then I have a few that I want to get rid of, so I'm just going to delete those. Again, making sure that I properly label everything in the image. And here I'm going to use a combination of deleting objects and then manually labeling a few of them. So this is a couple more here. And here's one on the edge, which is correct, so I will leave that one there. And now, if you make a mistake like this and do want to keep that, you can simply manually draw that in. And now there's a couple here I need to manually brush in, so I'm going to now go back to the brush tool, select it. I did mention there was a merge and edit. In this case, if I had two objects that really should be combined, I could actually enable this and then merge those together. Here, I'm just going to simply draw the missing ones in. And as I mentioned, I can adjust this. If the size guide is in your way, simply uncheck it for now. You can always add that back later. And here, let me show an example of the merge and edit. So I'm just going to confirm that one. A couple of things here. So if I want to merge and edit, I could simply draw that area in, and I could add that. So when I confirm it, I now have a new outline. And if I want to clean up a little bit, I'm going to take this off first. I can use the eraser tool and confirm it, and then turn off the eraser tool, and then the outlines will be updated. Once I'm satisfied I've identified everything, and I'm going to make one other edit. Let me confirm my drawn in objects. Again, it's good, especially when you have a lot of objects, just to, well, actually, let me select them. We have a lot of objects just to confirm that you've properly labeled everything. Otherwise, it'll be hard to converge. Now that I'm satisfied, I will add these labels to the training set. That's confirming what image, color, and I'll add that. Once it's confirmed, those labels have been added to the training set. You can see I have 2 images and 332 labeled objects. I could add a few more labels I'd like to, but let's run the training process. So I'm going to simply press the train, and it will bring up the training dialog. So it's set by default to 300 steps and 60 epochs. I'm just going to start with that for now and press the start button. At this point, 2 important pieces of information will be displayed. One is the training graph, and one is the deep learning output. As the training occurs, you can see textual representation of what the process is, where it stands, and what our loss rate is. Once we have enough data points, we can then look at the training graph. As the training continues, besides looking at the AI deep learning output, you can also now look at the training graph once enough data points have been plotted. As you can see, it is now slowly going down. As we complete the training, this will go lower and lower. And once the training has really met an optimal point, it will plateau out. If it has not plateaued and is still going down, it's an indication you need to add more labels to the training set and do additional training. Once the training is done, you can then press the Predict button in the AI Deep Learning Trainer panel, which will load the new model, and then you can test the new model by running a prediction on an image that is not part of the training set. Now that the training has been completed, we can look at our graph and see how it's flattened out. And we can also test the new model on an image. To do this, simply press the Predict button. The new model has now been loaded. Now we can select an image we have not trained on, zoom into a section, and press Count. Now that we've trained our model, we have a choice. If the model is good, we can use it as is and run predictions and use it in the normal process, and also use it in protocols. If we feel we need to do additional training, we just need to create more labels on images that have not been fed into the model, feed in new current labels into the new training set. A shortcut is, if our new model is better, we can take an image that hasn't been used in the model, run a prediction on it, make whatever little minor edits we need to make if there are still some, and then add it to the training set. And then you can, after training, run the prediction again. Once the model is good, then you can use it. One other note is, after closing this model, using the layout, close all tools, we can always go back into count size and see where it's located. Under the model manager, if I look at my models, I can now see the model I just trained. This model can then be used in prediction or in protocols. Thank you for watching this video. If you have any questions, please contact Media Cybernetics and we will be happy to help.